and start recording on, I don't know how to stop that transcription thing. It's absolutely meaningless. Actually, it's typing now. It's absolutely meaningless. All right. So we have 9, how many people? 9 people over there. And we have 1, 2, 3, 4, 5, 6. Well, it's okay. All right. So the first thing, I'm going to do a commit. You see, there's because there was some problem with the addendum, I have to discuss, there was something wrong. It didn't make sense the way they set it up. So I am putting this PDF for the addendum over here for you. So I'm just gonna add it. Let me just open it up. So the PDF over here, it should be good enough for now to have all the things that you want to know about your class. Okay, so it has the week 1 and week 2. So we are at the beginning of week 2, fundamental types and pointers, references, and stuff like that is actually going through. So I'll go through them, and when it's finalized, then I'm going to remove that one, and then you can actually go to SYL and see it over there. So I'm just going to add it here. So I'm going to go tortoise git, add. Commit and push. There we go. So that's added. You can bring it up later on and see what we're going to do and when things are going to happen. Now you have an idea until I make the online addendum. I discuss it and make sure everything's good with it. All right. Also, I'm going to make the recording for the other class available here for was this place that we talked about? Anyways, I'm going to make the recording available for this class. Let me see. Yeah, the other one was on Friday. And Friday, I just want to see if it was you or it was the other class. Also, let me these up. Yeah, so 3, 4, 5. Yeah, it's a good idea. Yeah, it's NDD. So I'm going to make the NDD lecture that we had because they had asked some good questions. We covered some stuff that we didn't talk here. I'm going to make the recording available. It's a good idea to just take a look at it and see what it is. And you know that all the codes are available to both of you, so you can actually take a look at the codes that were written for the other class too as we are going through them. That's that. So before we begin, any questions of any kind that you want to talk about at the moment? Any questions? Suggestions?
Do you record lab sessions as well?
I record, again, the answer is no, but yes. So the reason I'm saying no is that it's not a guarantee. I'll do my best, but sometimes the microphone fails, internet is bad, things like that. But I'll do my best. So don't count on it, but Hopefully it's going to be there. I'll
Yeah,
try to record
it's
it.
just for the review if in case we want. So it's there from where we can access this because I do attend lab in person, but sometimes for the revision I need them.
Yeah, I
Is
know.
it possible for them?
So this is how you do it essentially. So for all the labs and classes that I have, like for example, I just finished OOP345. When you click on the meeting and you open it, there
Yeah.
should be a recap up there. You see that? If you click on recap, the recording of the session, the latest recording comes up, and you can actually see it. That's one way. Another one is that weekly I upload all the stuff to YouTube. So you're going to see it's going to be on the playlist on the YouTube. So either this or that. So this is for, obviously, I'm not asking you to go.
All the playlists. Sorry for interrupting.
Go ahead.
Yeah, so I checked all the playlists on the YouTubes but I didn't find the previous lab.
Yeah, because I had to check. I've never used Microsoft Teams. I did the first one. The YouTube is not uploaded yet. I don't know if the last one, last lab, did we do it in, did I? Let me just give me a second. So your NEE lab was here, right? Let me see if there is something in here. No, there's no video over there. So that one is going to get uploaded to YouTube, sure. It's going to be uploaded soon, but it's not available now. Hopefully,
Any idea till when you'll upload it on YouTube?
as soon as possible.
Oh, okay.
You know what I can do? Let me just, I'm going to give you a 5 minutes break halfway through. When I do that, remind me, and I'll try to, because it's much faster at school, I'll upload it right now during the break. Just remind me, okay?
Okay.
And you need to give me the date, because I need that, okay? And then I'll upload.
Okay.
Okay. So, other than that, any other question? All right. Okay, let me close all these. So, did I talk about environment variables and stuff like that? We did not talk about, did we talk about those things? The syntax of main, how to receive arguments from the, did we talk about those things? I see one person is doing and everybody else is as if I'm talking some foreign language. Let me bring it up. So because the two classes go off sync, this happens. So from now on, at the end of the semester, I'm going to put someone responsible to tell me where we ended. Anyways, and I have to shut that up. My apologies. There we go. No, I don't see me talking about that. The last thing we went through was okay. Okay, so my question is, yeah, I remember that our class was up. Yeah. All right, so let me go through let me go through the way that compiler works. So okay. So fundamental types. We're going to first go through those. So we all know that there are, I just want to make sure, yeah. So first of all, we know about universal type of initialization in this class, hopefully. So curly brackets in front of anything, it means initialization. Okay? So that's a general way of initializing things. When you are writing a program from now on, if you want to set an integer to 0, that's how you do it. Okay? That means essentially you're defaulting an object. So instead of putting parentheses, curly brackets in front of it. Even when you are creating any type of class that you have. So if you have a class, whatever, foo, and this class has a constructor.
Professor,
Yes.
will you share the screen or not?
It should be visible to you. You don't
Oh,
see
no,
it?
now it's, I'm sorry, it was my network problem.
Can you see the screen?
Yep.
Okay, all right, okay. I thought that I'm sharing it, but okay, let me just. All right, so if we have a class like this and we want to initialize the class, foo, f, you write over here 10 and 20. That's how you do that, okay? It's a universal way of initializing everything. And the good thing about it is that with an empty curly bracket in front of anything, you can simply default them to whatever they are supposed to be. So use it this way from now on, okay? And also, regarding types, let's quickly go through types. I want to get off with this fundamental things, and then we'll continue whatever we are supposed to do afterwards. Type alignment. When we are talking about alignment, what does it mean, align of something? When you are dealing about a variable, any type of entity inside memory, the address in which that thing sits in memory, it should be in a way so the computer can access it. What do I mean? When you have a character, you put the character inside memory. Character has size of 1, right? So it can sit anywhere in memory. But let's say you put a short integer in memory. A short integer has size of 2 bytes. So if you start from the very beginning of the memory, the address of that short integer will be 0. Do we agree on that? Now, if I put another short integer after that, where can the address be? 2, correct? So because of that fact, it is impossible for a short integer to sit at an address that is not divisible by 2. It must be divisible by 2. So I cannot have a short integer at address 3. The compiler cannot comprehend that, because compiler has to count short integers to get to it. Because of that fact, it can't. So if I have an integer, integer has size of 4. So 0, 4, 8, 12, 16. These are the addresses that they can take. Are we okay down to this point? All right. And if it's a double, then it's got to be 8. Are we okay down to this point? Okay. Now, if we actually want to kind of put that thing under microscope, this is what we need to do. Give me a second. Let's say let me get rid of, so this is first of all, sizeof. What is sizeof? Sizeof gives you the actual size of the entity or type you put in front of it. It's actually an operator. It's not a function. Be aware of it. Okay, it's one of the few operators that they look like a function, but it's actually an operator. So when I say sizeof and I run this program, it's going to give me what is the size of an integer in this platform. I can say size of I, or I can say size of int. Do we understand that? Okay. Now, if I write over here integer a 10, if I say cout size of a, what's going to be the output of line 7? What's going to be the size of, what's going to be the output of line 7, Eric?
40.
It's going to be 40. Why? Because I have 10 integers, and it's going to be 40 things over there. We okay with that? Okay. Now, in here, I'm going to write this. Now, can anybody tell me what is the output of line 4?
8.
It's going to be 8. Why? Because it's a pointer. Arrays in their own scope, they have their own size. As soon as they get out of their scope, they don't know what the size is anymore. Essentially, what happens, I don't see the face of people at home, but over here, from the look of some of you, it needs explanation. So when you are in main, this is what you have. You have this in main that is created, and you have the array A that is actually, and let's say this is A, that is actually pointing to that array. Because they are all in the scope of main, size of A corresponds to the size of the entire array. But when you pass that one to PRNA, then that's not an array that is inside PRN anymore. That is essentially just the pointer over there that points to something that is outside of its scope. Therefore, PRN has no idea what is the size of the target. And because of that, it tells you what is the size of the pointer, not the function, not the array. This is one of the common mistakes that people do. They use sizeof to find the length of a string. Biggest mistake ever. Careful. Okay? So sizeof is that. But this is not the reason that I'm actually talking about. I just want you to know what sizeof is. Are we all good about sizeof? Know what sizeof does? Okay. So, let me actually make sure that it actually runs. No? Error? Why? Oh, I have to pass the... Okay. All right. By the way, that's 8. If it was this, then you know what that's going to be, right? Then it's 4. Yeah. Depending on what is the platform. If the 64-bit, then you have 8. If it's 48-bit, 48. If it's 8086 architecture, then it's 4 bytes. A pointer is 4 bytes. Let's say I have struct T1, let's call it. Okay? I'm going to put over here character C, double D, and integer I. Okay? Now if I say I'm going to do something else. So this is, let's save this. B size of 1.cv. So let's remove all this. So I'm going to go struct T1, and in T1 I'm going to write character C and double D and integer I. So if I say C out, size of T1, the outcome will be, don't answer anymore. I want someone else to answer. What is the size of this? He's compiling it. And that's somebody calling me. My apologies. I think I muted it. My apologies, my apologies, my apologies, my apologies. And it's going to take 3 years for it to mute it. I told you not to use your cell phones. Who has a cell phone on? Okay, my apologies. I thought I muted it on my watch, but it didn't sync. Anyways, so yeah, so what's going to be the size of this? What do you think? Like, common mistake says I have one character and a double, so that's 9 and plus 4, that's 13, right? But that's not the case. What happens is this, actually. It becomes complicated real fast, I'll tell you. So in here, I'm going to actually write T1. The size of T1 is actually 24 bytes. Why? Because of just what I just said. So when you put character at the beginning, it starts from address 0, let's say. It puts 1 character, right? Now it wants to put the double right after. Can it? No, because double must sit on the address that is divisible by 8. Therefore, it has to skip 7 bytes and put the double there. Now, it's putting an integer after. So far I have 16 bytes, right? And then it wants to put an integer after, correct? Now when it puts the integer after, it's 4 bytes later. Therefore it becomes 16 plus 4, that's 20, right? Well, wait a minute. If it's 20, and I want to have 2 structure of T1s back to back in an array, then the address of the character of the next one is going to be 20, which is fine. But the address of the double will be 28. It can't. So it has to not only fill the gap between the character and a double, but also have to add 4 dummy things after the int to make it 24. So every time the next one sits in a memory, all the values are sitting at the right place. So you think that you only have 13 bytes over there, but you actually have 24 bytes. You know how much memory gets wasted? So they say the best way to make it the minimum size possible is to always sort your attributes inside your structure from the biggest one to the smallest one. Like this is as if you're playing Tetris. You put the big one at the top, then the smaller one, then the smallest one after, so it kind of fills everything. So if I change this, then size of T2 will be much smaller. But they both have the exact same number of attributes, correct? Are we okay with this? We're okay? We're good with this, hopefully? We okay? Now, let's take a look at something else. If we have just primitive variables like integers and doubles and long doubles and things like that, that we know what their size are, we know how they are being aligned in memory. But when it becomes complicated like this, then the alignment becomes something tricky. What is alignment? Take a look. So essentially, if I run this, you'll see that the alignment of both is 8. It means any of those, if they start from an address that is 8, everything will sit in a proper address. So if I start from address 0 for the first one, then the next one must be address 24, and the next one address 24. But I could start from address 8. There is no problem with that. If I start from address 8, still all the small attributes inside the structure will sit at the proper place. Did I explain it properly? Do we understand what is the difference between alignment and sizeof? One person gives me a thumbs up. I don't know what people are. Are we good at online? Online people? One person is good? Actually, let me open the chat. Let me look at the chat too. I think in the chat. Yeah, sometimes give me something so I'm happy. So I feel like people are actually listening to me at home. All right. So that's the alignment and the size of. Okay. I would love to be able to pull something. And let me see how many people are there. You have 9 people, and that 11. Okay, so I asked this question in all my 3, 4, 5 classes before we continue to kind of see if you want me to cover pointers. If you guys want me to actually explain to you what pointers are, how they are designed, and how they work, this is actually what I do in IPC 144. But when I come to 345, many people really are not comfortable with pointers. So don't usually when I'm on other platforms, I do an anonymous poll, and people actually really tell me if they are comfortable with it or not. So I'm sorry if I'm asking over here. So how many people want me to actually go through pointers and tell from the beginning what they are and how they work? 1 person? 2? 3? Okay, 3 people over here. And people at home, can you type a yes over there if you want me to go through pointers? Type yes. Don't give me a thumb up because I don't. Oh, people are raising hands actually. Actually, raising hand is good. I can count it. Raise hand. Raise hand. It's a good idea. Raise hand. Raise hand. If you want me to go through pointers. I know we're going to fall a little behind, but I don't care. If it's going to help you, it's a good thing to do. All right. So we have. Okay, now you can bring your hand down. You'll be tired. Don't do it. Okay, so we have around 70% of people telling us that go through pointers. So I'm going to go very quickly. I'm going to go through it. I had the slide. So it's an IPC thing for pointers. So my apologies if you see there C references happening over there, but they're all the same. For us to understand pointers and things properly, we need to actually know that. So I'm just going to quickly go through it and kind of do a review on what we know about pointers. So when you were not here, majority voted to go through pointers, okay, to explain what they are. So I am going to do that. Let me just quickly find the pointers. Here they are. Okay. So I'll drop it in here. 3, 4, 5. VRNEE. Today's lecture. Sorry if I'm going quickly, but this is something that probably need to. First of all, this picture that I have, the illustration of memory over here is a bit wrong, because I have address 124 over here, but I don't draw the 24 in here, so it comes to 25. That's wrong. The one byte is missing halfway through. My apologies. This 124 is supposed to have 1 cell, and then the 25 starts from here. So let's start. This is the memory of your computer. It starts from address 0 and goes up to the amount of money you have in your pocket, okay? So the bigger RAM you have on your computer, the further your memory is going, okay? When you are writing a program, essentially, when you're creating a variable, when the variable is created, and obviously you see that I'm just putting the 3 right digits of the number is much bigger, okay? So when you create a variable someplace in memory, a place is allocated for you, and and it's being tagged with the name of the variable, and that's where you have access to do whatever you want to do. So when you actually put some value in it, depending on what that value, and same thing with a double. When you say double somewhere else, the amount of memory that you want is allocated. And when you set it to a value, those values are overriding the entire part that you have and that represents an array. So let's go back. Let's say I want to have a variable, because let's pretend that we are designing pointers. Let's say I want to create a variable that holds the addresses of other variables. Okay? If I want to create something like that, I will call that type a pointer. So essentially, I create a type, pointer, let's call it PTR. Like any other variable, it keeps, it sits somewhere in memory. And the architecture of this thing is 32-bit. That's why my pointer is 4 bytes. Okay? So first, number one, pointers are nothing but variables. Integer I, pointer PTR. Are we okay with this? Okay? People at home, the thing is covering the screen, so I can't see if you have any questions. Activate the microphone and talk if you have a question. I cannot see the chat. So if I say PTR is equal to 102, essentially it's like setting the variable to a value. It doesn't matter. 102 will go into PTR. It holds a value. But that essentially means that I want to point to the address 102, which doesn't belong to me. It doesn't make sense. So usually when you have a pointer, you want to point to something you have. It's like I have an address of an envelope. Hopefully that address goes to some place that you intended to go. You're just not going to write a random address on an envelope, right? You need. So for that, I need to actually be able to make that thing point to what I want. So I have to put 108 over there in front. So how do I extract that thing? So for that, I have to actually create another thing called address of. So I have to say PTR is equal to address of, an operator that extracts the address of anything. So when I say PTR is address of var, the compiler says address of, okay, let me extract the address, and puts the address in PTR. Therefore, PTR now has the address of var. Are we okay with this? Now, you have two ways of accessing a variable. Why do we create pointers? So we can have remote controls. We can put stuff in variables remotely. It's as if you want to send a package to someone, you write the address so someone else takes it to the address. You don't take it there. That's what the pointers do. So to do that, I need to tell to the compiler what the heck I want to do. Do I want to use the pointer, as I'm saying, actually set the pointer to something? Or I want to set the target of pointer to something? They are both numbers, right? So I need to be able to say target of PTR is equal to 2345. Therefore, I don't want to do anything with the pointer. I want to do something with what the pointer is pointing to. And therefore, that brings the 2345 into the variable. Are we okay down to this point? People at home, can you hear me? Activate the microphone, say yay or something. Can they hear me, you think? Anyone? Did I lose everyone? Seriously? Can somebody say hello?
Yep.
Oh, Okay,
Clear.
thank you. Finally, come on. Somebody give me something. Throw me a bone for heaven's sake. Okay. All right. So back to business. So essentially, my apologies for printf. Again, it was an IPC 144 thing. So when I say print %d var, 2345 is going to get printed. If I say printf target of PTR, still 2345 is printed. But if I say print %u, which is unsigned PTR, then where the address, where the variable is going to get printed. Are we okay with this? Are we all okay with this? Okay. So that's fine. This is fine and dandy. What if I want to have a double? So I should say PTR is equal to address of dvar, right? And therefore, having said that, I want to put 2345 in there. And then I want to say target of PTR is equal to a new value. There is a problem with that. I can't do that. This is wrong. Why? Because in here I said PTR and it overwrote 4 bytes, right? How the devil it knows this one is 8 bytes? The address that is a number cannot dictate what is sitting there. If I give you an address, 932 Young Street, you don't know what the heck is that. Is it an apartment in a building, or it's going to be a house, or it's what is it? It's a government building, it's a shop. You don't know what is sitting at that address. So our design is flawed. We can't use that. We cannot say pointer PTR. That's wrong. For that, we have to actually mention what type of a pointer I have. So I have to say integer pointer PTR. So it tells me this is a pointer whose job is to only point to integers. Are we okay with this? Now that we have this and I'm losing my voice, give me a second. Now, it always happens at the beginning of the semester. My apologies. Okay. So now I can actually say PTR is address of var, which is very fine. And when I say target of PTR, it knows what to put where. And if I want to do the same thing for the double, I have to say double pointer dptr. Therefore, it creates the same thing. But please appreciate the fact that the double pointer and an integer pointer, they have the same size. It doesn't matter what is the size of the target. The address is always the same. You're okay with this? Now I'm going to say double pointer dptr, and this double pointer dptr makes everything okay. Now I can actually extract the address. I can set the target. I can do all the good stuff that I've done with the other one, and it works perfectly fine. So this design is fit and good. But this was too clean and nice, and everybody can understand this. And C doesn't like that. They want it to be cryptic, and everybody to go, what the heck? So what they said, instead of pointer, we're going to put an asterisk, right? So they replaced the damn thing with an asterisk. So all the pointer stuff are gone with, and they actually belong to the type. So when you see an asterisk after a type, it means a pointer. It has nothing to do with an integer or double. It has something to do, but it's the target. Together, it's a new type. It's actually a pointer. We're fine with this? All right. And then for the address of, they used ampersand. So when you are saying d ampersand dvar, it's actually address of. Never, ever say integer asterisk PTR. You do that, you're never going to learn pointers. If you see an asterisk after a type, say as what it means. Integer pointer PTR, double pointer PTR. And dptr is address of dvar, not ampersand dvar. We good down to this point? Are we okay? So, but this was clear and nice too. So they had to make some kind of a thing that screw everything up, and that's the asterisk for target of. So target of is asterisk too. But the difference is that if the asterisk is a unary operator coming before a variable, it means target of. So it's the exact same thing. So essentially, target of this and target of that. Okay? And that essentially is it. There is no, I actually used to play a trick. So let me see if I have that trick over here and show you. And people would think, I'm going to actually bring that up. So to show you what it was actually. So what I did was this. Take a look. So in here, I'm going to say, why is this bringing this thing over here? There we go. So I'm going to say, add existing item. So in my program, that was so that was sizeof and align. C sizeof. So this is what I did. And some people got kind of disappointed. So I can say actually pointer P, oh sorry, integer pointer P, then I can say P and integer A, then I can say P is set to address of A, and address of A, then I can say target of P is set to 1, 2, 3, 4, and I can now say C out A. Is it like this? Yeah. And when I ran this, it actually, oh, it ran the other one. Sorry, wrong file. Copy. erg.cpp. Okay, back to business. So now when I run this, you'll see it actually works. Okay, so what the heck? So how could I actually write integer pointer and target of and all the good things that I've talked about? So the trick is essentially this. Define target of to asterisk, define address of to, and it just works, right? It just replaces it. So, so what I meant, what I said over there, I really meant it. It really means that. And if you actually call this stuff like that, then everything goes crystal clear. So that brings me to that how do we distinguish target of and pointer? So if it comes after type, it means type pointer. Integer pointer, double pointer, struct, employee pointer. And if it comes in front of a variable, it's a unary, and essentially it means target of P, target of T. A is equal to B multiplied by target of C, or E equals to target of M multiplied by C multiplied by C. You have to say it that way, then everything is clear. You're 100%. When I say E is equal to target of M, I know M is a pointer. C is not. C is not. These are multiplication. When I say B is equal to A is equal to B multiplied by target of C, I know C is a pointer. There is nothing hidden in here. It's 100% sure that this is a pointer and nothing but a pointer. then everything goes clear. So that essentially was an IPC 144 thing about pointers to make it clear so we know what's going on. And also the exact same thing about arrays. So when we are talking about arrays, where did I put it? I put it somewhere around here. Pointers and arrays are the same thing. So when you actually create a pointer, we talked about all that. Okay, when you create an array, you essentially have 5, and that's why I say it's wrong. You see, it's actually going to 129. It's not supposed to, but my apologies. But what I'm saying is that when you say integer AR5, AR3 is that. Essentially, when you are actually talking about an array like that, essentially it's a constant integer pointer that is pointing to the beginning of it. That's how it creates it. That's why AR by itself is a pointer actually to an integer. It's not. So when you create an array, you're actually creating two. You need to visualize it as if you create two things. One is a constant pointer. The other one is a chunk of memory that you're pointing to. And because of that fact, if you say target of AR is 2, 3, 4, 5, it's as if you are saying AR0 is 2, 3, 4, 5. Because that is essentially what it's pointing to. And if you say AR2, it's the same thing, but you can always say target of AR plus 2 is 5, 5, 5. So the two lines that you see over there, they're identical things. And that's called pointer notation for the arrays. Okay? And it works the exact same way. It doesn't make any difference. And that's what pointers and arrays are. So, and that's why when you're passing an array, you simply write a pointer in a function and you pass an array to. It's like you have a snake with two heads, right? They both lead to the same tail. And that's that. Questions? That was the quickest thing that I had. If I did that like this in IPC, they would have, anyway. So, so that's that. So I'm going to call it fake pointers. Okay. So pointer types, those are the pointer types that we have. The type def. Type def is essentially to creating a type out of another type that you have, especially when you have ginormous types that you want to reuse over and over and over. What you can do, you can simply write the type def, write the type that you have, and give it a new name. So that literally becomes the other one. Exactly the other one. So if you want to use types like that, that they are ginormous, it's actually very useful. Also, type def has a useful, it's useful with pointers. Say if I want to have an integer pointer, if I go type def, integer pointer int ptr, if I do something like this, then the bug that we have when we are saying, if I say integer pointer a and b and c, okay, what are the types of a and b and c? A is a pointer, b is an integer, c is an integer. They are not pointers. Right? That's the tricky part. But if I do that type def, so in here, I have to mention b and c are not pointers. But if I say int ptr, q, r, and s, they are all pointers. Okay? That's one of the good things about type def. When you put combined stuff together, type def creates a new type for you, which you can go through very simply and easily. Are we good with this? Also, in the era of C language, where in C language you could not create a type out of a structure, in C language we do it so comfortably we forget that in C we couldn't do that. In here, if I say struct student, I simply say student A. In C language, I couldn't do that. So one of the things that you may see in C code is for them to create a type out of a structure so they don't have to retype. So this was very common in C language to say typedef, struct, and don't put any name over here. Say character name, and say size unsigned student number, and they would write over here student. By doing something like this, they are essentially saying, give this structure a new name called student. And because of this, in C language, they didn't need to keep saying struct student something, struct student something. Student becomes a type name. It's very common in C language. You don't need this in C++ at all. In C++, that's the default. In C++, when you say struct student name and SDNO, struct becomes a type. There's no question about it. In C language, it's the exact opposite. You have to actually do it this way. So common in C to make a struct a type without recreating, without reusing struct. We're good with this? Are we okay down to this point? Don't worry, good parts are coming up. Generic pointers, void pointers. So I keep rewriting the thing, so copy. Okay. Oops. My compiler crashed. Sorry. This was the one, right? Email, I think. Okay, so hopefully that's fine. And that will be, this is E typedef. Yeah, and remember, please, typedef is for long names too, so we go through that. Okay, so say I want to type the contents, I want to print out the contents of a double pointer, of a double variable, byte by byte. I want to extract its type. Or say I want to copy a piece of memory from one place to another. So what can I do? If I want to write a function called copymem, okay, and I want to put something in a destination, the best thing to do is to put character pointers, because character is the smallest thing that we have, right? So in here, I can actually have character, pointer, destination, and constant character, pointer, source. And obviously, a size. Right? And if I want to copy one piece of memory to another, I can simply say over here for size t, I set to 0, I less than size, I plus plus. What I can do is to say destination I is set to source I. So now I can copy anything to anywhere using copymem. So if I have something like A and B is 1, 2, 3, 4, 5, 6, 7, 8, something like that. What I can do over here is copy mem. Obviously, I cannot put a character pointer. If I put over here address of A, it won't accept it because that's a character pointer. It's a double one. So I have to say reinterpret cast into a character pointer the address of the double. And for the other one, reinterpret cast constant character pointer the address of B and size of B. And now I'm going to say C out A. And 1, 2, 3, 4, 5 is going to get printed. Are we okay with this? I could simply say A is equal to B, but I have to. Are we okay with this? Are we okay with it? You look like a question mark. So I send the address of double as a character pointer to destination. So essentially, I made the double pointer, the double, an array of 8 characters. Okay, and the same thing, and then byte by byte copied everything instead of copying the whole thing, right? I call it copy mem. Now, the good thing is that you can copy anything like this, any piece of memory to anywhere else. All right? Problem is that this is crazy. Like, so I don't want to do this. I want to just write address of that and address of D and be done with it. For that, there is a way for it. Instead of actually doing a character pointer over here, you can get a generic pointer. That generic pointer is called a void pointer. So instead of writing this, so in here I'm going to say ABCDF copy mem with character pointer. So instead of writing that, I can write void pointer and constant void pointer. Okay? So if you do that, then you don't need this casting anymore. Because void pointer is an address without a type, which means any address can be written in it. It's a generic one. There's absolutely no need to cast anything to anything. Because this says just an address. I don't care what type. Problem is that because it's just an address, you don't know what's the target, right? Because you don't know what's the target, you should do the cast that you did for every single one, do it inside there. So instead of writing it like that, you can actually write this over here. Now you can do the reinterpret cast over here. Reinterpret cast to a character pointer, and then destination. It's the same thing. And in here, it's going to be reinterpret cast. To a constant character pointer source. So instead of doing it here, you do it once over here and everybody else can use it. So now I can have integer A 5 and B 5. And this one I'll 5. And this one I'll set it to 1, 2, 3, 4, and 5. Okay? Now what I can do is actually saying copy mem A, B, and in here I can say size of int multiply by 5. And it works for both of them. Why is it giving me an error? Oh, sorry, my apologies, my apologies. I think it's a good idea to have two different names. So I'll put over here I and J. That's better. Okay, so now it actually copies everything, and you can actually copy a piece of memory from one place to another. So that's what void pointers are, generic pointers. Are we okay with this? All right. Let me actually print this, so I'm going to say set to 0. Less than 5 and n++, and C out of I, n. Make sure it runs. There we go. Oh, 2, 3, 4. Did I miss one of them? Oh. That's better. There we go. Okay, so that's that. So G void pointer. All right, and now we can take a break. Okay, so 5-10 minutes break, and we'll come back and we'll continue. I can grab some water. Any questions before we go?
Yep. Can you put that lab session recording on YouTube?
Oh yeah, thank you. Do you know what was the date for it?
That was last Wednesday.
So take a look at the date. You find the date, I find the recording, okay? Like that.
Okay.
Was it 7th?
7th, yep.
Was it 7th? Okay. So that's that. So I'm going to... I need a browser. Oh, let me stop recording. 10 minutes are missing, so I'm going to... And that's something that happens all the time. Please, when we are coming back from break, shake me and remind me to actually record. But anyways, so I don't have to tell you that you cannot pass an array to another function and do the same thing. With arrays, range-based loops can be done only within the scope of the array. If you pass this array to another function, it's not an array anymore, it's a pointer. Remember that. So it only happens in the same scope. Obviously, later on, we're going to learn to work with containers like vectors and stuff, which this thing works. Those are objects. When you pass the references around, they pass all the properties around. And it works with all of them exactly as this one does. So if I run this, it essentially goes through the whole array. These range-based loops are extremely useful when we come to containers and algorithms. Okay? And that's it. Questions? Suggestions? Objections? All right. Soon we're going to get to all the good stuff, so the boring sessions are going to be gone. So, yeah. Any questions for people at home? You have a question? Anyone? No? Okay. Have a beautiful day, and we'll talk soon. Don't forget, we have a quiz on the lab that you're coming in. So be there. You have to be there. Have a good day.
shut down.